Hello everybody, this is ThinkParQ, the company behind BeeGFS speaking. We are sending you kind regards from Germany. Due to the pandemic situation, we couldn't join the HPC Summit. It is a great honor to participate, at least virtual. And a big thank you goes to our partner GARAOTUS, who organized this wonderful summit and invited us. My name is Marco. I'm hosting you today through this presentation. And the topic is accelerating extreme HPC scale-out environments with BeeGFS. So let's jump to the agenda and enjoy. All right, as mentioned previously, my name is Marco Merkel. I'm based in Munich and I run all sales operations and consulting services for ThinkParQ and BeeGFS. So we're enabling partners and end customers, train them on the product. And the topic of today is actually getting an overview about BeeGFS, some quick facts on the product, the enterprise features, how BeeGFS works, and then we are diving in some interesting use cases, and finally ending with a conclusion. BeeGFS, the leading parallel cluster file system, is mainly developed for performance. So it allows you to balance small and large I/O pattern at the same time. It is designed for scalability, so it is possible to increase the file system performance and the capacity seamlessly and non-disruptively. It is ease of use. The user space concept allows you to deploy it very easily, and it integrates into existing infrastructures. It is very robust because we are providing high availability designs which enabling continuous IT operations. Here are now some real quick facts on BeeGFS. BeeGFS is state-of-the-art, so for the server side it is operating in the user space. That brings us into the position that we really can say it's a hardware-independent parallel POSIX file system, and it operates like a software-defined parallel storage solution. It is available source, so the source is public available. You can download it on the beegfs.io. And since it's running in the user space, it's fully hardware agnostic to any kind of CPU architectures. So we are supporting x86, ARM, OpenPower, AMD. It is also agnostic to the interconnects. So we are supporting multiple networks like InfiniBand, TCP/IP, OmniPass, Ethernet, Rocky at the same time. It runs with various Linux distributions, so we are supporting RHEL, SLESL, and Ubuntu. And by the way, 98% of our installations are based on CentOS and Red Hat. The market is changing a little bit, so we are seeing now new distributions coming to the market, and we will support them soon. BeeGFS is enabled for NFS and CIFS re-exports, so we are supporting NFS and CIFS. And you can accelerate Hadoop natively. Since BeeGFS running on top of arbitrated Linux file systems like ext4, XFS, ZFS, so whatever makes sense to the infrastructure, it is super simple to manage and administrate. So it doesn't require any Linux patches. You don't need to compile kernels. And it's providing actually to the infrastructure a scalable multi-threaded architecture. Let's talk about enterprise features. The following slide compares in a table the BeeGFS community version versus the enterprise edition. The available community version can be used by any HPC data center, mainly for their scratch jobs. System integrators and vendors are not allowed to sell the BeeGFS cost-free version. Please have a check on the end-user license agreement. You find it on our web pages. The community version grants access to the community user group, the mailing list, you get free updates, and it allows you to use the binary packages and source code. Customers who do require high availability, quota enforcement, access control lists, and storage pool management can sign up on a level 3 support subscription, which enables the use of these features and have access to the ThinkParQ support team. You get next business day support plus early updates and hard fixes. The BeeGFS pricing on the support subscription is very fair and capacity independent. please contact our partner for further information. Now let's dive into how BeeGFS works. All right, let's dive into the BeeGFS architecture. As you see, we have here several small bees. We do have a client service, which actually is the only native Linux model to mount the file system. We do have a management service, which is actually registering all services and running a kind of watchdog mechanism all of this entire infrastructure. There's a metadata service, which is maintaining the striping information for the files. There's a storage service, which actually stores and distributing the file content. And there's a monitoring service, which is actually a GUI to monitor the system information. Let's dive into the concept a little bit more closer. The management service is actually the meeting point for all servers and clients. It watches and registers all services, it checks their states, it's managing the incoming jobs, and it is not critical for the performance because it doesn't store any data and it is not involved into the data streams. So typically we don't need a dedicated machine to handle this management services. Another important part is that this management service need to be set high available. That happens through a DRDB or an implementation into a virtual machine. It is also the central point where you're upgrading the infrastructure non-disruptively, so you can add additional metadata or storage nodes if needed. The key magic behind BeeGFS is definitely the metadata service. The metadata service stores all information about the data, like directory information, file and directory ownership, location of user data files on storage targets. Compared to traditional kernel-based distributed file systems, it is not involved into the data access between file and open-close process. That's handled through the underlying file system. And that brings us into the position that we are actually just forwarding client requests to the distributed storage targets. They have direct parallel file access on IO node level. And that brings us into the position to deliver full bandwidth to the clients and their applications and handle way more efficient small IOs and large IOs at the same time. That means faster CPU cores, improved latency. The metadata service manages one metadata target, in general any directory on an existing local file system. Typically, it is configured in a RAID 1 or RAID 10 for handling SSDs or NVMEs. It stores complete metadata, including the file system. In summary, the underlying file system, the interconnect, and the hardware components are the limiting factors for BeeGFS. Here we go with the storage service. The storage service stores the striped user file contents, the data chunk files. It is possible to have one or multiple storage services per BeeGFS instance. That allows you to manage one or several storage targets. In general, any directory on an existing local file system can be attached. Typically, it is configured in a RAID 5 or RAID 6 double parity set, so 8+2 or 10+2. Or you go for ZFS RAID Z2 volumes, either internally or externally attached. It can be also defined as a single HDD or NVMe or SSD device. It is possible to configure also multiple RDMA interfaces per server. So that means different servers, instances, will be binded to different interfaces, and that leads also to the different IP subnets for the interfaces for the routing to work correctly. So all in all, you get here resiliency and maximum bandwidth of your infrastructure. BeeGFS has also monitoring services, which allows you to get live statistics from the client and user side, analyze the storage infrastructure, setting up email notifications and thresholds. And behind this monitoring service is an influx database. It comes along with beautiful Grafana dashboards. BeeGFS and beyond. The BeeGFS user space architecture is enormous flexible, and it fits to small storage requirements. And it can be used as a converged solution on storage nodes to break NFS restrictions, for instance. On such a system, you're running lightweighted BeeGFS metadata and storage services on an SSD or NVMe on the node, on the storage node. And these nodes can be scaled linear. These services can be migrated into enterprise ecosystems by separating the metadata services on dedicated server components and managing storage pools under one single namespace across all tiers. Plus, you can go to beyond to speed up the scratch jobs and decouple nasty I/O pattern from your system file system by using BeeGFS instances for burst buffering and increase the efficiency of your entire cluster and ecosystem. Now some real cool use cases. The idea of BeeGFS is born, of course, into the HPC arena. After research time, the result was that a user space architecture will fulfill all modern I/O demanding requirements, from small converged setups to multiple petabyte deployments. Ease of use, maximal performance, and out-of-the-box and linear scalability are leading into a usage in different market verticals like AI, machine learning, life science, oil and gas, but also media and entertainment does require BeeGFS in their infrastructure and ecosystems. Here we go with use cases. First use case I want to bring up is the Max Planck Institute in Bonn and in Africa. This organization was the first institute which was capable to deliver a black hole visualization on a high resolution. That entire process took 4 years on 2 locations, so they selected data from space over satellite dishes, and the total capacity today is 8 petabytes. BeeGFS delivers here 120 gigabytes per second on super micro gear. If you are interested there is a link which actually guides you to the project description. We are pretty proud about that picture because this went through the press, and the most popular magazine who reported this picture was Forbes. Next customer is also very spectacular. It's NASA. NASA runs BeeGFS on a hyperwall. So it's a visualization wall with 128 screens and 128 nodes behind these screens. The nodes contain 190 gigabytes RAM, and the nodes are having a throughput of 512 teraflops per second. These nodes contain also NVIDIA RTX GPUs, so 128, and additional to this 512 teraflops, we're getting here 2.1 petaflops. BeeGFS is deployed on 1.8 petabytes, and we're delivering 600 gigabytes per second aggregated throughput on unit packard SSDs. The link guides you also to this fantastic hyperwall, and it's interesting to read. Next customer is in the AI business, so it's an institute called Simula. These guys running AI and machine learning algorithm on CPU nodes, on DGX systems, and it's a hybrid storage infrastructure based on NetApp E-series. So these guys using BeeGFS and beyond, and getting here out on a 500 terabyte infrastructure, roughly 200 gigabytes a second. AbbVie is a cancer research and biopharmaceutical project, which is a 1.1 petabyte deployment. So they are mirroring here the metadata on BeeGFS. They're using burst buffering and beyond, with beyond, and having a Mellanox EDR infrastructure. So it provides 18 gigabytes a second. That was established by a partner called Advanced Clustering. So they're combining here nodes. Finally, now the conclusion. So BeeGFS is really state of the art and the most modern parallel distributed file system on the market. Together with GARAOTUS, we are capable to deliver a turnkey solution for any I/O requirements. For you as a customer, it's ease of use. It doesn't require any changes to the existing workflows. And interesting wise, you can grow the infrastructure on demand, non-disruptively, linear on metadata level and on storage level. And that helps you to increase the efficiency and deliver projects on time. So you're getting more hardware for your budgets. So that means maxing out the TCO, and you're getting an ROI in shorter time. And GARAOTUS is a certified BeeGFS partner, which helps you to establish and configure any systems for any I/O requirements. GARAOTUS helps to invest into small or extreme HPC scale-out environments, powered by BeeGFS. Thank you for your attention. I hope to see you and meet you on the next HPC Summit. Stay safe. Have a nice day.